Here's a little help with your math packet that I'm giving you. This is completing the square, but these first three, they want you to actually convert from graphing form to standard form. So what we're going to do is just multiply this out. This thing will probably turn into a trinomial. I'm putting it inside the parentheses because I have to distribute the negative once I'm done. I can do these in my head, but if you can't do them in your head, you got to make one of these area models. And you would go x minus 1 times x minus 1. And that gives you x squared minus 2x plus 1. See how there's two x's? So this is x squared minus 2x plus 1. Or you can just look at it and go, you square this, and then you go the first thing times the second thing times 2, and then you square this. And then I'm just going to rewrite it as negative x squared, I'm going like this, plus 2x minus 1 minus 1. So hopefully you can do the next two on your own. I'm going to move to these. Convert the following quadratics from standard form to vertex form. So vertex form is when it looks like this. It's what we call graphing form, and we've been taught to complete the square. So I'm going to go ahead and take the 15 and get it out of my way. So I'm just going to subtract it from both sides just to get it gone so I can complete the square easily right here. Now I'm thinking of some number that would complete the square. So the number that completes the square is going to be half of these, like if you can remember your tiles that you use, it's going to be half of these x tiles, and then you, I'm going to actually draw a picture of that. So it's like you have an x squared, and then if you have negative 8x, and you're trying to complete the square, you're going to take half of the tiles and put it on one side and half on the other side. Trust me, I don't draw these all the time. And then, so these long skinny ones are my x tiles. And then I want to know how many little ones tiles are going to fit inside here to make a perfect square. And so I could count them, but I know that there's going to be 16. So you take half of this and square it. And so that's where I'm getting my 16 from. And I'm going to add 16 to both sides. And so that gives me y plus 1. And then this, we already know it's a perfect square. I can already write it as x plus 4 times x plus 4. So that's x plus 4 squared. Oh, wait, it was minus 4. I'm sorry. It's x minus 4. Remember, because these were negative tiles. There we go. And then I'm just going to minus the 1 on both sides. And we'll have okay, that is in graphing form. So hopefully you can just use that. If you didn't already know, you can use that to finish these problems. And then on the next page, it wants you to put them in vertex form and then graph them. So I'm going to put it in vertex form. I'll get rid of this constant. I'm going to take half of the negative 6, which is negative 3, and square it, which would give me 9. And add 9 to both sides. And then that'll give me y plus 2. This thing is a perfect square. If I drew it out, it would just look like the one I just did a second ago, and I know that it's going to be, you take half of this number, the coefficient of x, like that, and then I'll just add the 2 to, or I'll subtract the 2 on both sides, minus 2 on both sides. So we know that, remember, y equals a times x minus h squared plus k? We know that h is a horizontal shift and k is a vertical shift. So I'm going to shift it, h is 3. So I'm actually going to shift it 3 to the right and down 2, and then I can kind of fake it. I guess what I could do is, I know that right here, if I plugged in a 0 for x, I know that y would be 7, and I know that's going to be my y-intercept. So actually I'm just going to cheat and use the 7, and then there's an axis of symmetry right here, so I can just count, 1, 2, 3. So I'll go 1, 2, 3. So I know there's got to be another point right there, and I think that's good enough. Okay, so that's how you're going to do these. It's good practice for you.